So let's solve this one with synthetic division. A couple of things that would be good to remind us when we do that will be made known as in this example. To divide this, we have to understand what we're dividing into, and it has to be in the form of an x minus a c, but I'm dividing by an x plus a 2. So what do I make of that? Well, this is the same thing. X plus 2 is the same thing as x minus a negative 2. And that's important because then this becomes what I'm dividing, the negative 2, not the positive 2. So make sure you're clear with that every single time, that for division or synthetic division to work has to be in the form of an x minus a c. X plus 2 is not written in that form, so I need to rearrange it so it is written in that form in an equivalent fashion. So x minus a negative 2 provides what my c is. My c is a negative 2. Then I write in descending order all the coefficients. First one's a 5. The second one is it's a 0, isn't it? There is no x squared term, so I need a placeholder. Then a 6, and then an 8. All right, we're off to the races. Step number 1 in synthetic division is just drop that first term down, which is a 5. And I'm going to kind of draw a line because I'm going to add things here. So negative 2 times a 5 gives me a negative 10. Add those two terms together, negative 10. Next one is negative 2 times a negative 10 produces a 20. 6 plus 20 produces a 26. Next step, negative 2 times a 26 produces a negative 52. Add those two terms together, and that gives me a positive 44. Done. There's my solution, if I'm able to transition it back into it. So what are the coefficients, or what are the terms that go with this? Well, since I started with an x cubed and I factored out an x, my first term has to be an x squared. So I'll have a 5x squared minus 10x plus a 26. Oh, that's a negative right there. With a leftover of a negative 44 all over an x plus a 2. And there's my final result using synthetic division. And you're thinking, wow, I don't quite have it yet, but it looks magical to me. So I'm going to work at it because this looks like the way I want to do these long division problems.